Archimedes of Syracuse, circa 287 to 212 BC, was a Greek mathematician, physicist, engineer, inventor, and astronomer. Often regarded as one of the greatest mathematicians of all time, Archimedes made remarkable contributions to numerous fields, particularly geometry, physics, and mechanics. His works have not only had a lasting impact on mathematics but also laid the foundations for modern engineering and science. Archimedes was born in the city of Syracuse on the island of Sicily, which was a Greek colony at the time. His father, Phidias, was an astronomer, and it is likely that this familial connection sparked Archimedes' early interest in the sciences. Archimedes is thought to have been educated in Alexandria, one of the great centers of learning in the ancient world. In Alexandria, he was likely influenced by the works of Euclid and other prominent Greek mathematicians. After his education in Egypt, Archimedes returned to Syracuse, where he spent the rest of his life. Although not much is known about his personal life, it is clear from his works and inventions that he was deeply engaged in intellectual pursuits. He maintained correspondence with other scholars in the Mediterranean world, particularly with mathematicians in Alexandria, and his work reflects the rich exchange of ideas characteristic of Hellenistic science. Archimedes' most significant contributions were in the field of geometry. His work on the measurement of geometric figures, particularly areas and volumes, had a profound impact on the development of mathematics. One of Archimedes' most important achievements was his development of the method of exhaustion, an early form of integration that allowed him to calculate areas and volumes of irregular shapes with incredible precision. This method involved approximating the area of a shape by inscribing and circumscribing simpler shapes, such as polygons, and then refining the approximation by increasing the number of sides. Using this technique, Archimedes was able to calculate the area under a parabola and, more famously, the volume of a sphere and a cylinder. His work anticipated the invention of integral calculus by nearly 2 millennia. Archimedes also studied the properties of the spiral, that now bears his name. In his treatise on spirals, he explored the relationships between the curves of spirals and their areas. This work represented a significant advancement in the study of curves and motion and contributed to the development of kinematics. Archimedes is also famous for his approximation of pi, the ratio of the circumference of a circle to its diameter. Using the method of exhaustion, he inscribed and circumscribed polygons around a circle, increasing the number of sides to find upper and lower bounds for the value of pi. His result was an extraordinarily accurate approximation for the time and remained one of the best estimates for centuries. In addition to his contributions to geometry, Archimedes is renowned for his work in hydrostatics. The most famous story associated with him is the discovery of what is now known as Archimedes' principle, which states that a body submerged in a fluid experiences a buoyant force equal to the weight of the fluid it displaces. According to legend, Archimedes discovered this principle while taking a bath, leading him to exclaim "Eureka!" and run through the streets of Syracuse in excitement. This principle not only explained why objects float or sink but also provided a way to calculate the density of objects by measuring their displacement of water. Archimedes was also a brilliant engineer and inventor. His inventions were practical and often used in defense, particularly during the siege of Syracuse in 213 to 212 BC, when Roman forces attempted to capture the city. One of his most famous inventions is the Archimedean screw, a device used to lift water for irrigation and drainage purposes. The screw consists of a helical surface inside a cylindrical tube, and when rotated, it lifts water upward. This invention is still used today in some parts of the world for pumping water and handling materials like grain. Archimedes is also credited with creating ingenious war machines, such as the claw of Archimedes, which was used to defend Syracuse against Roman invaders. The claw was a type of crane equipped with a grappling hook, designed to lift and capsize enemy ships. Ancient historians described how Roman ships were lifted out of the water by the claw and then dropped, causing them to sink. Another invention attributed to Archimedes, though its historical accuracy is debated, is the Archimedes heat ray. According to some accounts, Archimedes used large mirrors to focus sunlight on approaching enemy ships, setting them on fire. While this story is likely more myth than reality, it demonstrates the legendary status Archimedes held for his creative genius in warfare. The lever and pulley systems, Archimedes is also associated with the famous statement, "Give me a place to stand, and I will move the earth." This refers to his work on the principle of levers. Archimedes made important contributions to the understanding of mechanical advantage, particularly in the use of levers and pulleys. He is said to have demonstrated the power of pulleys by single-handedly moving a fully loaded ship. His work in mechanics laid the foundation for statics, the branch of mechanics dealing with bodies in equilibrium. The works of Archimedes had a profound influence on both ancient and modern mathematics and science. In antiquity, his writings were studied by mathematicians in the Hellenistic and Roman worlds, and his methods influenced the development of Greek and Roman engineering. During the Middle Ages, Archimedes' works were translated into Arabic, and Islamic scholars continued to study his treatises. His influence was reintroduced to Europe during the Renaissance, when scholars rediscovered Greek mathematical texts. The 17th century French mathematician Pierre de Fermat and the physicist Galileo Galilei were both inspired by Archimedes' work on geometry and physics. Archimedes' method of exhaustion was also a precursor to the integral calculus later formalized by Isaac Newton and Gottfried Wilhelm Leibniz. One of the most remarkable instances of Archimedes' influence occurred in the early 20th century with the discovery of the Archimedes palimpsest. This 10th century manuscript, which had been overwritten with religious texts, contained previously unknown works by Archimedes, including his treatise The Method of Mechanical Theorems. This work revealed how Archimedes used mechanical reasoning, involving the balance of weights on a lever, to solve problems of geometry, providing insights into his genius that had been lost for centuries. Archimedes died during the siege of Syracuse in 212 BC, when Roman forces, led by General Marcus Claudius Marcellus, captured the city. According to legend, Archimedes was so engrossed in a mathematical problem that he did not notice a Roman soldier approaching him. When the soldier ordered him to come with him, Archimedes reportedly replied, "Do not disturb my circles," referring to a diagram he was working on. The soldier, either enraged or confused, killed him. Archimedes' death was a great loss to the scientific world, but his ideas lived on, influencing generations of mathematicians, scientists, and engineers. His insights into geometry, calculus, hydrostatics, and mechanics formed the cornerstone of many later developments in these fields. The methods he pioneered, particularly his rigorous approach to problem solving, embody the spirit of mathematical inquiry that continues to drive the discipline today. Archimedes was not only one of the greatest mathematicians of antiquity but also one of the most creative scientific thinkers in history. His work in geometry, calculus, mechanics, and hydrostatics transformed the way we understand the physical world. His inventions, whether practical tools or war machines, demonstrated his ability to apply theoretical principles to real-world problems. More than 2 millennia after his death, Archimedes' legacy remains vital, continuing to inspire mathematicians, engineers, and scientists alike. His blend of theoretical brilliance and practical ingenuity sets him apart as one of the towering figures in the history of human thought.